Backpropagation is a term for a simple little thing that the first ever AIs had to learn to become what they are now. And that is something you should know. But what is it? And why is it so important? In our previous video, we explored the birth of modern AI, but we only touched on the tech that made it possible. Today, we're going to dig deeper into one of the key technologies, backpropagation. So sit tight and get ready to dive in. First, we'll take a quick trip back in time to understand the history of neural networks. However, for a comprehensive overview of the history of AI, I recommend watching my video on the journey of AI from Turing to GPT-5. The link is in the description down below. So, the idea of neural networks originates from the human brain. They are made up of layers of interconnected neurons that transmit and process information the way a human brain does. That means I have neurons, you have neurons, and in fact we all have neurons. The concept is believed to have been initially conceptualized in the 1940s by pioneers such as Warren McCulloch and Walter Pitts, who created eventually the first mathematical model of a neural network. Nevertheless, the road to practical uses begins with the perceptron, the first artificial network created by Frank Rosenblatt in the 1950s. Good name, by the way. But it was the limitations of the perceptron in handling non-linear functions that led to the need to look for an innovation. The fundamental breakthrough in machine learning came in the 1980s with the advent of backpropagation, which took neural networks to a completely different level. But what is it actually? It is an algorithm that was popularized by a 1986 paper by David Rumelhart, Geoffrey Hinton, and Ronald Williams. Backpropagation, short for backwards propagation of errors, is like the magic trick that made neural networks much more effective at learning. Without it, the AI revolution we're witnessing today wouldn't have been possible. So how does backpropagation actually work? Imagine you have a neural network trying to recognize handwritten digits. When you feed an image of a digit into the network, it processes the image through its layers and makes a guess. If the guess is wrong, backpropagation helps the network learn from its mistakes. It actually involves a series of complicated steps, which starts with the forward pass. In this step, the input data, which in our example is the image of a handwritten digit, is passed through the network, layer by layer. Each layer performs some computations and transforms the data slightly until it reaches the output layer, which produces the network's guess. Then comes the calculate error stage. The network's output is compared to the actual desired output, the correct digit, and the difference between the two is called the error. This error indicates how far off the network's guess was from the correct answer. Our model then moves to the backward pass. This is where backpropagation comes in. The error is propagated backward through the network, starting from the output layer and moving towards the input layer. During this backwards pass, the algorithm calculates how much each neuron in each layer contributed to the final error. And lastly comes the adjust weights stage. As the error propagated backward, the algorithm adjusts the weights of the connections between neurons. These weights determine the strength of the connection and are crucial for the network's ability to learn. By adjusting them in the right way, the network reduces the error, improving its performance on future predictions. The process is repeated many times with different inputs, allowing the network to learn and improve its accuracy over time. To make this concept more concrete, consider this scenario. On a sunny day, you're teaching a child to throw a ball into a basket. Initially, the child's throw might miss, but each time they try, you provide feedback on how to adjust their technique. You might suggest they throw a bit higher or with more force. With enough practice and feedback, the child learns to consistently make the basket. Backpropagation in neural networks works in a similar way. It's the feedback mechanism that helps the network improve its performance by continuously adjusting and refining its weights and biases through repeated iterations. Now, you might wonder, why is backpropagation so important? Well, it's because it enabled neural networks to learn complex patterns in data. Before backpropagation, training deep neural networks, that is, networks with many layers, was extremely difficult and inefficient because there was a need for human intervention each time the model was impeded by an error. Backpropagation made it possible to train these networks effectively and paving the way for powerful AI systems we have today. So let's look at a practical example. Modern AI applications like ChatGPT, image recognition systems, and speech recognition all rely on neural networks trained using backpropagation. Think about trying to train an AI to recognize a cat in a photo. Without backpropagation, you'd have to manually tweak the network's parameters every time it made a mistake. A nearly impossible task given the complexity of the data. Backpropagation automates this process, allowing the network to learn from its errors and improve over time. For instance, in image recognition, a network trained with backpropagation can look at thousands of images of cats and gradually learn to identify features that are characteristic of cats, like their ears, whiskers, and eyes. Similarly, in speech recognition, a network can learn to distinguish between different sounds and words by analyzing large amounts of audio data and adjusting its parameters through backpropagation. But it doesn't stop there. Backpropagation is also crucial for natural language processing, which is used in chatbots like ChatGPT. And when you ask ChatGPT a question, it processes your input through multiple layers of neurons to generate a response. The quality of these responses depends on how well the network has been trained, and backpropagation plays a key role in the training process. So to sum it up, backpropagation is a game changer in the world of AI and machine learning. It allowed neural networks to learn from their mistakes and improve, leading to the sophisticated AI systems we use today. Whether you're using ChatGPT to write essays, relying on AI to recognize your face in photos, or even using AI to translate languages, you're benefiting from the power of backpropagation. And that's it for today's video. If you want to dive deeper into how backpropagation works, check out the links in the description for more detailed explanations and examples. Don't forget to hit the like button and subscribe, and also hit the bell icon while you're at it, so you never miss an update on our AI adventures. Thanks for watching, everyone. This is Dennis. See you in the next video.